Namaste everyone. Here is a problem. A rocket is fired vertically upwards with a speed of 5 km per second from the Earth's surface. How far from the Earth does the rocket go before returning back to the Earth? And we have so many values given: mass of the Earth, radius of the Earth, and the gravitational constant g. Now, most of the students go wrong in selecting the formula. As soon as you see this formula, as soon as you see this problem, immediately it strikes to the mind that you can apply the formula v square is equal to v naught square plus 2ax. It is quite usual. Most of the students try to solve this problem with this formula: v square is equal to v naught square plus 2ax. Final velocity square is equal to initial velocity square plus 2ax. But um, this formula is wrong, because here this formula can be used only when the acceleration is uniform throughout the journey. Wherever the object moves, a should be same. So this is a uniform acceleration formula. But here the object is thrown with a velocity of 5 km per second. Remember, 5 km per second is almost half of the escape velocity. So when a ball is thrown with or any object is thrown with 5 km per second from the surface of the Earth, it will reach to such a height that throughout its journey, the acceleration due to gravity will not be same everywhere. It will be different at different points. So this formula cannot be applied. So how to solve this problem then? You have to go for the conservation of energy principle. Throughout the journey of the particle, the total energy must remain conserved. Its potential energy and kinetic energy may keep on changing, but their sum must be same. So let us assume that Earth is almost a spherical body like this, and this is the center of the Earth. So this is the radius of the Earth. And when you throw the object with certain speed, like 5 kilometers per second, let it reach a height h from the surface, like this. I'll name this point as A, this point as B. Now, from this point, if I write total energy, that is kinetic energy at A plus potential energy at A, should be same as the total energy here. Kinetic energy at B plus potential energy at B. The law of conservation of energy must be true, because it is a law. It's a law of nature. So this formula will help you to solve the problem. And recalling all the formulas, kinetic energy at any point for any object is half m squared, because it is always positive. It never changes the formula. It is always same. But potential energy due to Earth on any object, gained by any object when it is kept on the surface of the Earth or at any height, potential energy due to Earth is negative minus g mass of the Earth, mass of the object, by the distance from the center. I'll take this as distance from the center, which can also be written as minus gravitational constant mass of the Earth, mass of the object, divided by r plus h, I can write. And when the object is on the surface itself, h is 0, so you can replace this with the r only, radius only. Okay, we will start solving the problem. We'll write the formula first. The total energy at both the points must be same. So kinetic energy at A plus potential energy at A must be equal to kinetic energy at B plus potential energy at B. So when you write the formula, half m v square plus potential energy at A minus g, mass of the planet, mass of the object, divided by, when you are at A, the distance from the center is only r. H is 0, is equal to kinetic energy at B is 0, because we have to see the highest distance, height traveled by the particle. That means you have to wait till its velocity becomes 0. So here the kinetic energy is 0 plus potential energy at B minus g, gravitational constant, mass of the Earth, mass of the object, divided by height from the center, r plus h. H is the unknown factor here. That is what has to be found out. And remember here, m and this m can be taken outside the bracket, which can be cancelled with this m on the right hand side. So this m and this m outside the bracket gets cancelled with this m. So I don't show that in the steps. I'll directly substitute the values. So what are the values? So formula is ready with us now. Just substitute the values. Okay, half, m is not needed. V square. V square is, that velocity of the object is 5 kilometers per second, which can be written in SI unit as 5 into 10 to the power 3 meter per second. Kilometer is 10 to the power 3 meters. So I can substitute the value like this. Half v square 5 into 10 to the power 3 whole square. M is already cancelled. Minus G is given here. You have it here. 6.67 into 10 to the power minus 11. Mass of the planet, here it is Earth. Mass of the Earth is here. 6 into 10 to the power 24. 10 to the power 24 divided by radius of the Earth, because we are here now, A. Our distance from the center is radius of the Earth itself. So radius of the Earth is 6.4 into 10 to the power 6 must be equal to, this is 0, but kinetic energy at B, potential energy at B minus G, again minus 6.67 into 10 to the power minus 11. Then mass of the planet, that is mass of the Earth, 6 into 10 to the power 24 divided by R plus H. R is radius of the Earth. It is given 6.4 into 10 to the power 6 plus H. So we need to calculate H. So this problem is actually easy. Oh, you have to be very calm and you should be writing step by step very clearly so that you will get the answer. And here, this is 25. So this part, 25 into 10 to the power 6 by 2. Because 5 square is 25, 10 to the power 3 to the power 2 is 10 to the power 6. Minus, let me calculate this. Yeah, cancel. 6.67. I'm calculating this and this part, the second part of the equation. 6.67 into 6 equal to divided by 6.4. 6.4, that is equal to 6.25, that is enough, into 10 to the power. So answer is 6.25 into 10 to the power. Here is 6. So when it comes to the numerator, it becomes 10 to the power 7 minus 17. And then this 24. 10 to the power minus 17 and 24. Minus 17 and 24 is 10 to the power 7 is equal to, again here, minus 6.67 into 6. That we got it earlier. We could have written it earlier only. So 6.67. It is here. 6.67 into 6 into 6. It is 40.02. Okay. 40.02. Only that much we can do in the right hand side. Sorry, 40.02. Minus 40.02 into 10 to the power. This minus 11 plus 24. It is 13. 13 divided by 6.4 into 10 to the power 6 plus H. This is the first step. Okay, next step. This will be 12.5 because by 2 is 12.5. But I want 10 to the power 7 if I want to subtract this number with the previous one. Then what I'll do? So this is 12.5 into 10 to the power 6. So I will donate 110 to 10 to the power 6 from here. I'll write it as 1.25. 110 I have given it to 10 to the power 6. 10 to the power 7 minus 6.25 into 10 to the power 7 is equal to minus 40.02 into 10 to the power 13 divided by 6.4 into 10 to the power 6 plus H. Okay. So when I subtract this, okay, clear? 1.25, of course it is 5. 1.25 minus 6, but minus 5. Sorry. 1.25 minus 6.25. It is 5. It is minus 5 because this is smaller. So minus 5 into 10 to the power 7 is equal to minus 40.02 into 10 to the power 13 divided by 6.4 into 10 to the power 6, a number, plus H. Okay, so I'll bring minus 5 into 10 to the power 7 to the right hand side, and I'll take this as a whole to the left hand side. 6.4 into 10 to the power 6, a number, plus h must be equal to minus 40.02 into 10 to the power 13 divided by minus 5 into 10 to the power 7. So that implies 6.4 into 10 to the power 6 plus h is equal to, so 40 divided by 5, it is 8. 40.02, clear. 40.02 divided by 5 is equal, minus sign gets cancelled. 8.004, which I can write it as 8 only. So 8 into 10 to the power, this 7 and this 13, it is 13 minus 7, 6 is equal to 6.4 into 10 to the power 6 plus h. Now take this term to the left hand side. 8 in minus 6.4. 10 to the power 6 is common for both. 8 into 10 to the power 6 minus 6.4 into 10 to the power 6. So 10 to the power 6 common is equal to h. h is equal to, so it is 1.6. 1.6 into 10 to the power 6 meters from the surface of the earth. So it reaches a height which is equal to 1.6 into 10 to the power 6 meters. If you remove 3 here, then it will be 1,600 kilometers from the surface of the earth. So that is the way in which you have to solve. Looks to be very long, but it is not very long. It is a very short problem. Once you practice these types of problems once or twice, it will be very easy. So only conservation of energy principle will solve this. This equation is wrong. So we are asked to calculate how far from the earth does the rocket go. It goes to a height of 1.6 into 10 to the power 6 meters. Thank you.